this is a rather introductory talk on TDD, though it's gonna cover some important details that will make the adoption of TDD easier on your side. So let's get started. My name is Jov. I'm very passionate about extreme programming practices and software craftsmanship in general. Hence, I tweet about those things, and I also blog about those things. I also co-organized the Diffternity conference in that regard, so if you Google it, you will find out more about it. So let's do a little theory about TDD. As we all know, TDD stands for test-driven development. So it is definitely not a testing strategy. It has nothing to do with the traditional quality assurance as we know it. Is TDD a tool? Well, we couldn't buy TDD or subscribe to TDD and then point it out to our code base and expect it to do some magic. However, the test suite that will come up afterwards can be seen as a tool because it helps us to maintain the behavior or the functionality of the software that we've written. The way I see TDD is as a skill. To me, TDD is a very specific way of writing software. There are different ways of writing software. TDD is just one of them. So I can describe TDD to you in some 5 minutes or maybe less, but it takes lots of time to master TDD. So it takes lots of practice and discipline and dedication. So because, as I said, it is a specific way of writing software, in that sense, it establishes a workflow. And that workflow goes like this. We start from the red phase, which means we have a failing test. And important point here is that if the test that we are writing is not compiling, that's also a failure. So we are working towards making it compile in order to be able to run it. Once we have the test able to run and it's failing, we are trying to make it green. And our aim is to get it to green as soon as possible. Once we have a green test, we can focus on refactoring in order to make the code better. And of course, once we are done, once we are satisfied with what we've done at that point of time, we can go back and write another test and so on. So of course, this is what you will find everywhere on the internet. However, there are lots of little details in between these steps, and that's the goal of this presentation, to go to some of them and explain them. But first, let's see why folks are doing test-driven development. So the first thing is the customers. I've seen a tweet recently where somebody was claiming that they don't write tests because their customers don't care about the tests. And that's absolutely right. Our customers couldn't care less whether we are writing tests or not. However, the hell they care about the behavior or the functionality of the software that we are writing, especially over time. So nobody really wants a broken software after, like, a release that we are making. So we have to take care of the functionality. In that regard, we are maintaining the behavior of the thing that we are shipping to our customers. Because when we do TDD, we write not a single behavior without writing a failing test for that behavior first. And in that sense, it's impossible to alter or break a functionality that was covered with a test, because the test will fail and we will have a clear indication that something has changed that shouldn't have changed. So in long run, we are fighting regressions and we are bringing it down to zero. What about test after? Some people do test after, maybe that works for them. But I'm gonna ask, how many times you've been in a situation where you have a bunch of hundreds lines of code and one or maybe two tests, even worse with some vague names like test 1, test 2. I don't know about you, but I've been in that situation more than a handful of times. And guess what? I've trusted those tests and I went into refactoring and broke significant functionality. Of course, that's how we learn. So to me, test after is pure guesswork, because there is always some behavior that we couldn't imagine after the software is written. We couldn't really think about, and we wouldn't catch that. And of course, when refactoring happens, we'll hit that spot that is not covered with a test, and everything goes downhill. There are basically two test-driven development styles known today in the world. The first one is the Chicago school. You can also meet that somewhere as a Detroit school of TDD as well. And on the other hand, we have the London school. One important thing is that those are not mutually exclusive. And when you're working on a particular solution, you can do both of them simultaneously. That's that's something that you can do. Let's take a look at the Chicago School. It is also known as classicist and inside out. And here inside out means the way of designing the software. So we are starting from the core of the thing that we are building, and we are working outwards. So while we are refactoring, we are emerging some design, and that design emerges from inside outwards. That's why inside out. One specific thing about this test and development style is that we are always designing in the green. What I mean by that is once we have a green test, to get it to green, there is a thing in TDD known as fake it till you make it. So in order to make a failing test pass, you do anything that comes to your mind. That's why we say fake it till you make it. So you can hard code values, do those kind of things. Once the test is green, you go to the refactoring in order to make it nice, and most of the time there are some designs emerging from there. But this refactoring, while we are doing the refactoring steps, we always aim to be always in the green. So all the time during these steps, the tests are still passing. On the other hand, we have the London School. It is also known as mockist or the outside in. And here again, outside in means on the way of designing the things. So it's more suitable when you have some insights or like some core basic idea on how do you want to structure the things. So you are going from the outside of the system and then you work inwards. One important aspect of this TDD style is that the design happens in the red. So as I said, it's known as mockist because it involves some mocks. So the mocks are used in order to distribute responsibilities across suitable collaborators. And that happens while we are in the red phase, while we are having a failing test. In that sense, there is way less work that you have to do in the refactoring step. So that's also something that is specific about this TDD style. As I said, it involves some mocking, and mocks are always controversial. So when this TDD style uses the mocks in order to describe and satisfy relations between different collaborators. Of course, as with everything, people can abuse the mocks and end up with some brittle tests that are basically checking some how something is written, like some implementation details rather than real functionality. So there is not, so they end up fighting the tests, and maintaining the test is a nightmare. So that's why mocks are not very popular, because they abuse them. But of course, as I said, if we leverage the mocks in order to design the things, it's not that bad. And for the rest of this presentation, I would like to go through a working example, which is basically a search functionality. So we are going to be working on, there is some criteria that we want to satisfy. So we are going to be doing a cities lookup for a given query. And the query has to have at least 3 characters. That's the criteria. So these, let's list first the criteria that we want to show. Then the query should be case insensitive. We don't care whether the query is camel case or capital case or whatever. And of course, we have a match when the query is contained in the name of the city. The question is, where do we start? One good tip, especially if you are a beginner in TDD, is to just scratch out some tests that are coming to your mind initially on some piece of paper, and then stress over think about all the possible situations. Just write whatever comes to your mind first, and then as you go, most probably you'll figure out some other things, and then you'll cover them as well. Another thing is that we can start with the zombies. And of course, zombies is an acronym that I think James Graining came up with. So the first 3 stands for 0, 1, many, and here we refer to sort of 0, 1, and many as an output of the system that we are building. And while focusing on these 3 sort of outputs, we define the boundary behaviors, interface definitions, and exceptional behavior. So let me give you an example. Imagine you are working on some sort of catalog, and you are searching for products by barcode. So with the 0 case, you are clearly defining a boundary behavior, because you have, let's say, an empty catalog. So what happens when you have an empty catalog? You have zero output, you have a boundary behavior. And of course, while you're working on 0, 1, mainly you are defining the public interface of the thing that you are building. And of course, you have to think about exceptional situations. What happens when, let's say, for example, you have you're searching for a barcode that is not included in the catalog at that moment. So maybe that's going to be an exceptional behavior that you have to take care of. Ultimately, by applying the zombies, you will end up with simple scenarios and simple solutions. So your tests are going to be simple scenarios that will describe the thing, and on the other hand, you have a simple solutions, meaning that the code that you came up with will be simple. So let's get started with a searching exercise. We are starting off by writing our first test. What happens when you have no cities found? We are always, it's an always great idea to start from the assertion. That's the tip number 1. Why? Because whenever we start, when we are starting from the assertions and working upwards, we are going to end up with a very minimal thing that is required in order to get to the point that we want. When we start from the arrangements, there is always possibility, and most of the time happens, to end up with things that are not very relevant for the given test, and then like end up with things that are not necessary. So what we're gonna do, we are gonna start from the assertion, and the goal here is to reflect the expectations, to reflect the behavior that we care about, and that's the ultimate goal. So we start with the assertion, and at this point, as we spoke about, we have a failing test because it does not compile. So our aim at this moment is to get it to compile first in order to be able to run it and then watch it fail. So let's make it compile. This result that we are expecting here should come from somewhere, and they should equal to an empty list. So the result's gonna come from something that I'm imagining at night right now as like sort of searcher that will expose a function search that will take the query as an argument. And that searcher, I'm just gonna instantiate it here, though it is nowhere to be found. It's not existent. So I'm just gonna emerge it. I'll create a class for it, and now because it's this class is empty, it doesn't have anything. Back to my test, what I have is it is still not compiling because the search function is not exposed from that searcher. It does not contain any functions. So again, just the aim is to get it to working. We are gonna extract this function. We're gonna emerge this function in the searcher. So now we have this function, and because this is Kotlin, by default it adds this to do, which essentially is gonna throw an exception. If this was Java, it would be sort of something that like throw new, I don't know, not implemented whatever exception, that kind of things. And now because my test at this moment compiles, I can just run it and watch it fail. And that's what I'm gonna do. So I'm running the test, and it says that the operation is not implemented. It's very important. I couldn't stress enough how important it is to watch the test fail and make sure it fails for the right reason. Because if the test does not fail for the reason that you're expecting it to fail, later on it will not tell you when some behavior is being changed and this test is not failing. So that's the idea. Now, back to our code. How do we make this test pass? As we said before, fake it till you make it is an option. So the easiest thing that comes to our mind to make that test pass is just return an empty list. And now I run the tests, and as I can see, the tests are working well. Now I have a green test. And now I can just declare a win. I can declare a victory on this, because looking at the test, if there are no cities, if I have no cities at all, regardless of the query that I'm passing, I'm gonna have an empty list. So in that sense, I could be done. And that's why it is important, as I said before, to scratch out some tests that you are thinking about, that you have in your head initially. And then you will know how to continue afterwards. So another thing that I am thinking of is like what happens when I have a city found. So I've started with 0, now I'm going to 1. What happens when I have a city found? So again, I'm going to start from the assertion. I'm going to expect is a list of Rotterdam, let's say, the city where I live, as a result. And again, the result is going to be the searcher.search, passing their ERD as a query, because ERD is contained in the city of Rotterdam, in the name of the city. And of course, I'm gonna just create new instance of the searcher. And here we have a compiling test that I can go ahead and run. And of course, we are gonna run all the tests. And as we can see, the old one is still passing. This one is failing, the new one. And it's failing for the right reason. We are expecting Rotterdam. We got empty list. And now back to our code. How do we make this work? Again, fake it till you make it. The easiest thing that comes into mind is just to add an if and say if the keyword is ERD, then return a list of Rotterdam. And that would make the test pass. And it does. And now back in our function, in our production code, what we can do here is like we can just sort of sense how this algorithm is going to evolve. But one of the worst things in software is to make assumptions. So what we can do better is to have more evidence on the things that we want to do. Like for example, here we don't have evidence how this algorithm would evolve. And in order to get more evidence, we can write more tests. So which tests do we write to get that more evidence? So we can write, there is a thing called triangulation. So the terminology comes from fixing a point in multi-dimensional space. And in terms of software, it means when we have zero-dimensional algorithm, we're going to return a constant. And to cover that behavior, one test is enough. If you have one-dimensional algorithm, we need at least 2 tests, and so on and so forth. So that's the triangulation. So we can triangulate now in order to get more sense of how this algorithm will evolve. So let's go ahead back in our tests and write new test and see what happens when you have another city found. So we are gonna start again from the assertion. This time we are expecting a list of Bitola, the city where I was born, as a result. And then again, the result's gonna be coming from the searcher.search, and at this moment, I am passing the query bit. And one important point is that part of the criteria was that the query should be case insensitive, and that's something that we are gonna catch here. So I'm passing on purpose query that is case insensitive, and it should match the city that starts with capital case. So that's gonna be, again, I'm gonna create instance of the searcher. And now I have the test compiling and working fine. So I can run it. And of course I'm gonna run and watch it fail. That's very important. Does it fail for the right reason? Yes, it does. I expect something, and I got an empty list in reply. So how do I make that work? Again, fake it till you make it. I'm gonna just add another else if, and here I would say if the keyword is bit, just return list of Bitola. That will make the test pass. Now I can focus on refactoring this code, and definitely this is a time when I can start refactoring. But I don't have an evidence what happens when I have more than one city being replied for a given query. So when I have more than one match. But also in interest of time of this presentation, I'll just go ahead and write one more test to get proof of that one. In software, especially in TDD, procrastination is probably the only place where it makes sense. So the more you delay your decisions on like extracting things, making abstractions, that kind of things, the better you are. Sometimes, especially here, is easier to come up with just a little bit more duplication and then fix it rather than come up with an abstraction that will be maybe wrong. It's gonna be cheaper to address the duplication. What's the duplication that I'm talking about? This else if that I'm adding, because here it is pretty much clear how this algorithm will evolve, just adding else if. So as I said back in the tests, let's write the test what happens when you have multiple cities found. Again, from the assertion, we're gonna expect list of, let's say, new arc and new port as a result. And when that's gonna be happening, we are expecting that to happen when we search for keyword new on the searcher, and of course instantiate the searcher. Now the test is ready to be run. We run it, we watch it fail. Does it fail for the right reason? Absolutely. How do we make it work? Fake it till you make it. Just add an else if there, keyword is new, and then return list of new arc and new port. Run the test. They are working fine. All four of them are passing. So now we can reflect to the code, and what do we see here is definitely a point that we can start refactoring. What do we refactor actually? How do we know what to refactor, what to do? The ultimate goal is to push the data up the call stack. And when I say up the call stack, I mean more towards the entry point of the program. At this point, the tests are exercising my program, so they are my entry point. So I want to push the data up the call stack towards the tests, and I want to keep abstractions in my shipping code. That's something that we learned in the pragmatic programmer. I think I'm not mistaken. So the first step towards pushing the data up the call stack is to group the data together and separate the data from the abstractions, and it's gonna be easier to move it around. You can take any approach to do that. The way I prefer to do it is take as little as possible small steps, like baby steps, and keep the tests running all the time. During those little steps, I want to make sure that I'm not breaking anything, and I'm constantly running the tests. So first of all, let's take a look at all the replies that I'm getting. So this is the responses that I'm getting as a reply from this search function. So what I can do, the ultimate idea is to group these together because they want to stay together, because they are part of the results. So what the first thing that I can do is I can focus on the first result, let's say on the Rotterdam. And what I can do first, I can put it into a collection, and I can assign this collection into a variable. And of course, I wrote some code that is not being taken in consideration anywhere. It is not being used. But just in case, I make sure that I didn't break anything. So I'm just going to run the tests because I might have compilation issue and that kind of things. So as I said, this code is unused at all. So it does not affect anything. And now inside the if, what I can do, I can try to replace the hard-coded Rotterdam by abstraction, like try to get it from the cities. So how am I going to do that? I'll just take the first that contains ERD. And I'm gonna assign that into a variable. In this case, I name it match. And now here, so I'm just gonna run the test to make sure this new line is not breaking anything. Of course it shouldn't, because again, it is not being used, just in case I make sure. And here is the match. So I can now replace the Rotterdam, the hard-coded value, with a match that I found from the collection. And of course, run the test, make sure I didn't break anything. So as you see, I take as little as possible steps and run the tests in between. So now, if we take a look, we replaced one of the hard-coded things with an abstraction, and we have one to go, which is the ERD. But basically, this ERD is equal to the keyword. So if we just replace ERD with a keyword, we're going to remove all the hard-coded data inside this if. So that's one step forward. That's a good step. And of course, we make sure we didn't break anything. And we didn't. Next, we can focus on the following if, like the next if. And in this case, the result is Bitola. So what you can do, we can pull it in the initial cities collection that we came up with. So we are going towards grouping the data together. So we move this value in the initial collection. We run, make sure we didn't break anything. Then what I can do, the condition inside that if, I can pull it in the initial if, in the primary, in the first one, and then I can say or that condition. And in that case, whenever I have the keyword bit, it will get into the first if for sure. But here, the thing is that I have to also keep in mind that BIT is lowercase and the city name is starting with a capital case. So what I have to do, I also say that I'm gonna ignore the case. Of course, this is a language feature that comes with Kotlin. I'm just gonna leverage that one. I make sure I didn't break anything, so the tests are still working well. And what I can do now with the else if, I can absolutely eliminate it altogether. And of course, I removed it and I make sure the tests are still working. Now, if we reflect back to the match that we had before, one thing to notice here is that we are getting the first from the cities, but what we can do is, because we are essentially we are returning a collection of things, we can use another operator. We can use filter, and the filter is going to return a list of all the things that are containing the keyword and ignoring the case. In that sense, we are going to rename the match with matches, then we are going to return the matches. Again, run the tests, make sure we didn't break anything. And of course here, if we reflect, we have now a duplication that we can address. Not only that the matches are appearing twice, but also we have logical duplication. Basically, we are creating new variable all the time, assigning something to the variable and then returning the variable. Instead, what we can do, we can inline this and we can directly say return cities filter and then whatever contains the keyword by ignoring the case. And of course, we run the tests to make sure we didn't break anything. There are basically 3 steps that you have to remember in this case. First step, come up with a new thing. Make sure you didn't break anything. Replace the old thing that you want to replace. Again, run the test, make sure you didn't break anything. Then delete the old thing. And again, run the test, make sure you didn't break anything. So just 3 simple steps that you follow and everything's going to be fine. So now, as I said, I make sure I didn't break anything. As you can notice, I'm running the test way too often. And that's good because at any point of time after each step, I want to make sure I didn't break stuff. And if I have like 2 or 3 steps in advance that I'm thinking that I want to take, that's fine. I can take 1, 2, 3 steps and then run the tests. It will be easier to reword for me if I reduce the time between running the tests. But the point here is that the tests are running very fast. Like at this moment on this machine is 48 milliseconds. It's like nothing. So that allows me to actually, it gives me the privilege to be able to run these tests. If I have flaky tests, if I have slow tests, no, people just don't want to run such tests, and that's a problem. Let's continue. Now we can focus on the last if condition, and basically we can also take a look at this result, which is the Newark and the Newport cities. We can pull them up in the initial collection again. And now what we want to do, we want to get into the first if condition. So now we have these 2 keywords that are like we have this or, but how do we make sure that we are going to enter this if? Well, we can just put true there. If true, we'll make sure that we are going to get into that if. Now we run the tests. We make sure that we are still green. And what we can do with the else if, of course, we can eliminate it. Again, make sure we didn't break anything. And now what we can do here, we have if true. Basically, the entire if condition is unused. I mean, doesn't make much sense. We can just eliminate that one. Again, run the tests, make sure we didn't break the things. If you reflect back to the function itself, what we have done, we have separated the data from the abstraction. Now it's easier to work with this. We can move the data if you want. We can do stuff like that. However, back in our code, in the tests, there was one condition left that we didn't take care of yet, which is the short query. What happens when we have short query? We don't want to make a search at all. So let's go ahead and write the test for that. What happens when you have a short query? Again, we start from the assertion. We are going to expect an empty list as a result whenever we search for RO. So RO is not long enough. And we are going to instantiate the searcher. Now we can run the test because it does compile. We run. We have out of 5 tests, 1 is failing. And does it fail for the right reason? Yes. it does. We are expecting an empty array, however, an empty list. However, we got Rotterdam back because RO is included in Rotterdam. So how do we fix this? Well, we can wrap the return into an if, and we can say if the keyword length is greater or equal to 3, only then perform the search or do the filtering. Otherwise, just return an empty list, and that makes the test pass. So now we're done with the test. That's fine. Back into our shipping code. One thing to notice, and you should always look for this thing in your code, is to move the variables or whatever you have, move it closer to its usage. So whatever you have, like call to a function, whatever, move it closer to its usage. That's gonna allow you to spot things that can be, I don't know, immersed somewhere. Maybe they're asking you to create an abstraction, that kind of thing. So just move them and then watch what happens. So here, what I can do, I can move this collection of cities inside the if because it's only place where it is being used. Of course, I'm gonna run the test to make sure I'm not breaking the things. And if you take a look into entire if inside, this is something that wants to live together, so we can extract a function out of this. So we are creating cities containing keyword function, and inside we have this collection and the algorithm. And we are gonna keep this as a private function here in the searcher for now. We run the test, we make sure we didn't break anything. And back into initial search function, what we can notice here, we are mixing levels of abstraction basically. So we are working with functions like cities containing and empty list. However, we are also checking length on a keyword, which is way lower level of abstraction compared to the other things happening in this function. So what we can do, we can also extract a function out of it, just a little check function. So this is it's just gonna check if the length is greater than 3. So it's sort of validation point. Run the test to make sure everything is working fine. Now if we reflect back to the entire to the initial function, the search, we can see that actually it looks kind of okay. However, what's wrong here is we are violating the single responsibility principle. Why do we do that? Because in this class, what we do is we are making the validation of the query and we are also performing the search. So there are at least 2 reasons to change this class. If you want to change, let's say, the length of the query, if you want to change the way we are filtering out the cities, let's say now it is containing, what if we want to do it with like starts with, there is another reason. So we have at least 2 reasons to change this. So what we want to do, we will continue refactoring towards getting rid of the single responsibility principle violation. So the first thing that we can do is this is sufficient length. We want to push it out from this class. So how do we do this? First, we are going to create a class here internally inside this initial class in the searcher. At this point, it is unused, and we can just paste the function is sufficient length inside. And of course, this is unused, like nothing is used. So adding this thing is of no consequence. Still, we just make sure by running the tests. And now, inside the initial function, what we can do, instead of calling this sufficient length that is part of the searcher, the function, we can create an instance of the keyword check and call the function in there, inside. We also make sure we didn't break the things, make sure everything still works. And now what we can do with the class that we came up with, we can extract it outside of this. So it's gonna live into its own, into a standalone file. That's good. We'll come back to this a little bit later. But now if we go back to the searcher, the function is sufficient length is not being called, so it's unused. What we can do, we can delete it. And again, make sure it doesn't break anything. But back to our search function, what we've introduced here is a logical duplication, because anytime we call the search, we're gonna make new instance of the keyword check. That's a logical duplication. That's not very like performance-wise okay. We want to address that. So what we can do? Well, we can inject it as a constructor argument. You may say why I'm not, let's say, making an instance inside the searcher. So whenever I make a instance of the searcher, it will make new instance of the keywords check. The thing is that now I'm working alone, so I'm making the decisions alone. If I was pairing with you, we would have made that decision together. The point here is that given a chance, do pair programming, do mob programming. These are some things that you are gonna do together, and those are important things. So that's the moral of the story. So now I'm injecting the keyword check. I'm calling the keyword check as a collaborator. And of course, to do this, I am using the automated refactorings from the studio that I'm using. Whenever you have a chance to use automated refactorings, leverage that. That's a lot of work done for you by the studio. If you don't have it, then you can consult always the book from Martin Fowler, which is the refactoring book. But yeah, as I said, if you have a chance, use the studio itself. Make sure everything's still working. And as I said, we're gonna get back to the keyword check. Basically, the problem here is that still we want to push the data up the call stack. So this tree hard-coded here is a configuration. So what we wanna do, we want to configure this class on instantiation level. Like whenever we are making new instance of the keyword check, we want to be able to configure it properly. So what we can do, we can push this also as a constructor argument. And whenever we are instantiating keyword check, we can pass that configuration as an argument. What's going to be the minimum required length? We make sure everything is still working. And if we go back to our searcher, now we have the initial search function, and inside we have the cities containing. But more importantly, if we go back to our tests, now I'm showing one because it's gonna be too much if I show all of them in one slide. What I wanna show here is this keyword check tree being passed as a constructor argument for like instantiating the searcher, and that's reflected in all the tests. The point is that because I'm using automated refactorings, all this work is done for me. That's what I wanted to say. Now, in the searcher, the cities containing is also a function that, first of all, we want to push that data that we have inside the collection. We want to push it up the call stack, but also we want to align the levels of abstraction inside the searcher itself, so we can do again the same steps that we've done with the keyword check to push this into another collaborator. But in interest of time, I'm gonna skip all the baby steps. I can just assure you that I've done all the steps, but basically what I came up with is a class that I named city catalog. It takes the cities on a creation level because the cities are sort of the configuration of the class. And then the algorithm is just the cities containing inside is the algorithm to filter out the things. And as you can imagine, out of this class, what we can do, basically we can extract an interface and then we can have different implementations, that kind of things. That's something that we don't have approved, we don't have a need now. That's just a class. All fine. In the searcher, I'm injecting both collaborators, and what I have in my initial search is very simple, very basic condition flow here, if else, like control flow, and I'm just consulting the two collaborators that I'm injecting. More importantly, back in my tests, again, the city catalog and the configuration for the city catalog has been emerged. Like you see, we pushed all the data towards the tests, and that was done mostly by the studio itself. One thing that I want to point out here, let's take a look at the multiple cities found, is we have the arrange act assert. So if we go part by part, what we are doing, we are constructing a searcher by passing a keyword check that mandates at least 3 characters as a query length. Then we have some city catalog that takes some cities, and 2 of them are Newark and Newport. When we search by passing keyword new, we should get back list of Newark and Newport. And what I'm trying to point out here is that the relation between the data that we have in the arrangement and in the assertion Makes total sense given the act here. And then this test, in that sense, is very sort of clear. When you take a look, it's super easy for you to understand what's going on. You have some arrangement of, like, from the arrangement and the assertion, it's easy to understand what's the API of the system and how does it work. And that's the essence. That's the point of, like, having small tests that are gonna reveal their intent and be clear what they're testing. So to recap, as we saw, TDD was never meant to be hard. It should be an easy thing. But of course, in order to get to that point, you need a lot of practice, and you have to have a good knowledge and understanding about design and design principles, architectural principles, if you will. So the more you learn, the more you know about the architecture in general, the easier it will be for you to work with TDD on a TDD way. And when they say about advanced TDD, when people talk about advanced TDD, there is no such thing as advanced TDD. The advance in the test-driven development is like your ability to listen to your tests when they're telling that, okay, this thing that you are testing is hard to test because like when you see something hard to test means that something in your structure is wrong, some API is wrong. So when the more you learn to listen to those signals from inside your test, that's sort of the advanced in the TDD. There is not such thing other than that as advanced TDD. Of course, I want to share some resources with you. The first one is the comparative case study. It was recorded by Uncle Bob and Sandro Mancuso. And the objective of this one is to make a comparison between the London School of TDD and the Chicago School of TDD. It's very interesting. I can recommend that one. Then the other one is the world's best intro to TDD, and this one really is the best intro to TDD in the world. It is by JBrains, and good portion of it is for free. Just go ahead, check it out. You won't regret any money that you're gonna spend here. I couldn't recommend this one enough. And of course, my own test-driven development screencast. I share a lot of these kind of things on YouTube. I am trying to publish weekly episodes, so you'll find a lot of things that we spoke about today and some more in there. So go ahead and check it out. Everything is for free in there. Of course, there are some books on TDD. The first one is the Test-Driven Development by Example, written by Ken Beck. The other one is the Growing Object-Oriented Software Guided by Tests. And those two are the best for me, the best books on test-driven development. Probably there are more. These two are just my favorite ones. And as I said before, books are great, resources like that are great, but practice makes it perfect. So the more you practice yourself, the more you're gonna learn. So that's gonna be about it. Thank you so much for the time and attention. Find me on internet. My DMs are open. Please shoot me any questions that you might have. I'm gonna be more than happy to answer them. Thank you.
Well,
Great.
amazing talk. Amazing talk by Job. Job is here with